Let knowledge flow like a river, without any hindrance. Don't make it like a stagnant pool.
Hello everyone. I'm PS Chatterjee, and a warm welcome back to my channel. Before we dive in, a quick note for my non-civil engineer viewers: while we'll be tackling some technical concepts today, please feel free to follow along. Simply treat the engineering terms as numbers and focus on applying the Excel process to your own DIY spreadsheet projects. In my last two videos, we thoroughly covered the theoretical aspects and the design of a doubly reinforced beam for bending stress, first through a detailed PowerPoint presentation, and then applying it in Excel. Today's video, titled Shear Stress in Doubly Reinforced Beam, IS 456 Part-03A, is an Excel presentation, and a perfect DIY project, especially for my fellow civil engineers, and this is also continuation of Part 03. If you're new to the channel, I highly recommend checking out Part 1, Part 2, and Part 03 of this series first. And for an even stronger foundation, my IS 456 singly reinforced beam design, bending moment, shear force and deflection limits and checks in Excel series, parts 1 through 7, will be incredibly helpful. In this episode, we're going to dive into several critical shear stress calculations in Excel. To help us visualize the tasks ahead and recap the necessary steps for shear design, let's now move to our next slide. Alright, we're currently looking at Excel formula number 6. We concluded Part 3 last week, so our journey today will commence from this point. Let's begin.
Setting the case_type formula. Now, once again, I am back on the sheet named design_01. And I will put the formula in the case_type cell, which is cell F13. The formula for case_type is, equals to if, open parenthesis, n, open parenthesis, check_03 equals to, within quotation, OK, comma, VU, less than or, equals to 0, close parenthesis, comma, within quotation, VU, with double note of interrogation, comma, if, open parenthesis, n, open parenthesis, check_03 equals to, OK, comma, VU, greater than, 0, comma, or, open parenthesis, ASV, less than, or equals to, 0, comma, ASV, equals to, blank quotation, close parenthesis for or function, close parenthesis for, and function, comma, within quotation, ASV, with double note of interrogation, comma, if, open parenthesis, n, open parenthesis, VUS, equals to, within quotation, nominal, comma, ductility, equals to, within quotation, no, close parenthesis, comma, 1, comma, if, open parenthesis, n, open parenthesis, VUS, equals to, within quotation, nominal, comma, ductility, equals to, within quotation, yes, close parenthesis, comma, 2, comma, if, open parenthesis, n, open parenthesis, VUS, greater than, 0, comma. Ductility, equals to, within quotation, no, close parenthesis, comma, 3 comma, if, open parenthesis, n, open parenthesis, VUS, greater than, 0, comma, ductility, equals to, within quotation, yes, close parenthesis, comma, 4, comma, blank quotation marks, close parenthesis, 6 time, 4-6, if function. Understanding the case underscore type formula. Apparently, this formula looks like a zombie. And it's consisting of 6 applications of the if function. But, if we concentrate our focus on this formula, we will find that we are using the same structure, repetitively, simply by changing the facts and figures. The simple meaning of this formula, part by part, is: first part, if check underscore 03 equals to OK, and the value of VU is less than or equal to 0, it will notify us to provide the value of shear force VU by typing VU with double note of interrogation. Part 2, if check underscore 03 equals to OK, and VU is greater than 0, but the value of ASV is less than or equal to 0, or the cell for ASV is blank, it will notify us to provide the value of ASV by typing ASV with double note of interrogation. Part 3, if Excel finds the value of VUS equals to nominal and ductility equals to no, then it will return us the value of case underscore type as 1. Part 4, if Excel finds the value of VUS equals to nominal and ductility equals to yes, then it will return us the value of case underscore type as 2. Part 5, if Excel finds the value of VUS is greater than 0 and ductility equals to no, then it will return 3. Part 6, if Excel finds the value of VUS is greater than 0 and ductility equals to yes, then it will return 4. Finally, if check underscore 03 is not equal to OK, it will keep the cell as a blank. Now I am pasting the formula on the cell, case underscore type. Presently we are seeing the cell case underscore type, as a blank cell. Alright, let's look at our dashboard. Right now, our VU value is 50 kilonewtons, and ASV is 201.06 square millimeters. Also, note that check underscore 03 is showing OK. However, notice that the cell under the VUS heading is currently blank. Because of this, our case underscore type cell is also blank. For demonstration purposes, I'm going to manually type nominal into the VUS cell for now. In a real scenario, this cell would automatically show either nominal or a calculated VUS value. Witness the transformation. See the magic? As soon as I typed nominal, our case underscore type now displays case type 1. Now, let's accept the ductility. I'll change the ductility cell from no to yes. And just like that, the case underscore type updates to case type 2. Error handling in action. What if we forget to enter a value? I'm going to change VU from 50 kilonewtons to 0 kilonewtons. See how VU now shows with a double question mark? That's our reminder to input a value for VU. I'll use the undo option to revert VU to its previous state, and you'll see case type 2 returns. Similarly, if I change dia underscore 03 from 8 mm to 0 mm, we get ASV with a double question mark, a clear reminder to provide a value for ASV. Again, I'll undo that change, and case type 2 reappears. This shows how our system helps ensure all necessary data is provided for accurate case type determination. Now, you'll notice we haven't seen case type 3 or case type 4 yet. That's because these specific case types are entirely driven by the VUS value, and that's something I'm still in the process of setting up on this dashboard. Task number 7, Conditional Formatting for Case_Type. Now, after continuing with setting the Case_Type formula, we need to provide conditional formatting for this cell. The conditional formula for conditional formatting for the cell, Case_Type, is, equals to, is number, open parenthesis, Case_Type, close parenthesis. The simple meaning of this formula is, the condition will be true if Excel finds Case_Type to be a number. If it's a number, it will return true and follow the action we instructed. To apply the formula for conditional formatting for the cell Case_Type, first copy the formula from the formula box. Next, select the cell Case_Type. From the ribbon, select the option for conditional formatting. Select New Rule. From the menu list, select the option, Use a formula to determine which cells to format. In the dialog box, paste the formula. Now, select the Format option. Select the option Fill, and select No Fill or White color as a fill color. To accept this condition, click on OK and then Apply. For the standard fill, fill the cell with yellow color. This white color or no fill color for the cell will be activated when the provided logic is true. Presently, our logic, check_03 equals to OK, and the value in the cell VU is equals to 50 kN, and the value in the cell ASV is equals to 201.06 square millimeter. Because of this, presently on the cell, Case_Type we are seeing, case type 2, we already know, this is a number not a text, hence our condition is true, so we are not seeing any color for the cell Case_Type. Because we have selected no fill or white color as a fill color. Now, when our logic is false, you will find the yellow base color. Testing the conditional formatting. Test number 1, now, I am changing the value of VU from 50 kN to 0 kN. Look. Our cell, Case_Type turned into yellow. Test number 2, now, I am changing the value of ASV from 201.06 square millimeter to 0 square millimeter. Look. Our cell, Case_Type is still yellow. By the help of the undo option, I am returning to the previous position. Test number 3, now, I am changing the value of MU from 150 kN to 250 kN. Look. Our cell, Case_Type turned into yellow. Because this time check_03 is showing check, with double note of interrogation. Once again, by the help of the undo option, I am returning to the previous position. Task number 8, creating a display for shear design conditions. Now, I am going to develop a little display for the condition under which we are performing our shear design. It will help us to visualize the relation between the inputted data and the outcome result of this inputted data. The formula that I have to type in the merged cells, G13 and H13, is, equals to, if, open parenthesis, or, open parenthesis, Case_Type, equal to, 1, comma, case underscore type, equal to, 2, comma, case underscore type, equal to, 3, comma, case underscore type, equal to, 4, close parenthesis, comma, VLOOKUP, open parenthesis, case underscore type, comma, table underscore F, exclamatory symbol, cell $A$3, colon, cell $C$6, comma, 2, comma, 0, close parenthesis, comma, within quotation, no case type found, close parenthesis. By the help of the define name option, the name of these cells is condition. This formula is a combined formula of if, plus or. The simple meaning of this formula is, when the value of the cell named as case underscore type is 1, or 2, or 3, or 4, the VLOOKUP formula will find the text from the second column of the table, table for stirrups, on the sheet named as table underscore F. I have already explained that table in this video. In this formula, case underscore type is our lookup value. On the basis of this lookup value, VLOOKUP will search for a specific number or text from the table underscore F. Cell A3, colon, cell C6, is the lookup array for the VLOOKUP function. We can consider this as a boundary for the VLOOKUP function. 2 is the column index for the VLOOKUP, that means, it will find the text or number in this column. At the end of this function, 0 stands for an exact match. Now, by copying this formula from the formula box, I am pasting this on the cells called condition, and we are seeing the text, tau c max, greater than, tau c, greater than, or equal to, tau v, plus, ductility. Now I am changing the value of ductility from yes to no. Look. Our condition changed to the text, tau c max, greater than, tau c, greater than, or equal to, tau v. So we can say our display for the condition is in full functional. Task number 9, conditional formatting for condition. Conditional formatting for the cell, condition, and the formula that I am going to use for that is, equals to, open parenthesis, condition, equals to, no case type found, close parenthesis. I think I need not explain this simple formula, hence skipping the explanation of this formula. Now, by copying the formula from the formula box. Next, selecting the cell condition. From the ribbon, select the option for conditional formatting. Select New Rule. From the menu list, select the option, Use a formula to determine which cells to format. In the dialog box, paste the formula. Now, select the Format option. Select the option Fill, and select the yellow color as a fill color. To accept this condition, click on OK and then Apply. This yellow color for the cell will be activated when the provided logic is true. Presently, our logic, check_03 equals to OK, and the text in the cell is tau c max, greater than, tau c, greater than, or equal to, tau v, plus, ductility. Presently our condition is false. Now, for the time being, I am deleting the text nominal from the cell VUS, and we are seeing the text no case type found, in yellow fill, as a proof of success. Now, switching our focus to the heading, shear stress calculation. We're looking at 8 cells with distinct headings, enhancement, ductility, beta, greater than or equal to 1, tau c, with unit Newton per square millimeter, tau v, with unit Newton per square millimeter, tau c max, with unit Newton per square millimeter, VUS, with unit kilonewton, and spacing, SV, with unit millimeter. Regarding enhancement and ductility, I've already discussed these topics in detail, the enhancement of calculated tau c and ductility, and how to develop these two cells in Excel. You can find this information in my videos titled, Singly Reinforced Beam Design, Shear Stress. Part 03, and Part 04. Task number 10, now, let's look at beta. The formula for beta is equals if, open parenthesis, check underscore 03 equals to, within quotation, OK comma, if, open parenthesis, if, open parenthesis, FCK less than or equal to 40, comma, 0.8 multiplied by FCK divided by open parenthesis, 6.89 multiplied by PT underscore PROV, close parenthesis, comma, if, open parenthesis, FCK greater than 40, comma, open parenthesis, 0.8 multiplied by 40 divided by open parenthesis, 6.89. Multiplied by PT underscore PROV, close parenthesis, close parenthesis, close parenthesis, close parenthesis, less than 1, comma, 1, comma, if, open parenthesis, FCK less than or equal to 40, comma, 0.8 multiplied by FCK divided by open parenthesis, 6.89 multiplied by PT underscore PROV, close parenthesis, comma, if, open parenthesis, FCK greater than 40, comma, open parenthesis, 0.8 multiplied by 40 divided by open parenthesis, 6.89 multiplied by PT underscore PROV, close parenthesis, close parenthesis, close parenthesis, close parenthesis, close parenthesis, comma, blank quotation, close parenthesis. Understanding the beta formula. Let's break down the simple meaning of this formula, step by step. Argument number 1, if, check underscore 03 equals to OK. In this portion, Excel will first check if the cell named check underscore 03 contains the text OK. If it finds OK, it will proceed to argument number 2. Argument number 2, if, this if has 4 parts. Part 1, if, FCK less than or equal to 40, then, the equation for beta is, 0.8 multiplied by FCK divided by, 6.89 multiplied by PT underscore PROV. If this calculated value is less than 1, it will return 1 as the value of beta. Part 2, if, FCK greater than 40, then, the equation for beta is, 0.8 multiplied by 40 divided by, 6.89 multiplied by PT underscore PROV. It will also check the calculated value of beta. If this value is less than 1, it will return 1 as the value of beta. Part 3, if the value calculated in Part 1 is more than 1, it will calculate the value of beta by following the same formula when FCK is less than or equal to 40, and the formula is, if, FCK less than or equal to 40, the equation for beta is, 0.8 multiplied by FCK divided by, 6.89 multiplied by PT underscore PROV. Part 4, once again, if the value of calculated in Part 2 is more than 1, and FCK is greater than 40, it will calculate the value of beta by following the same formula. If FCK greater than 40, 0.8 multiplied by 40 divided by 6.89 multiplied by PT underscore PROV. The ultimate portion of this formula belongs to argument number 1. By using blank quotation marks, we are telling Excel that if check underscore 03 is not equal to OK, then the cell should remain blank. By copying this formula, I am pasting on the cell with heading beta, and we are seeing the value of beta as 1. Task number 11, now, it's time for tau C, or design shear stress. The formula for tau C is equals to, if, open parenthesis, check underscore 03 equals to, within quotation, check, with double exclamation, comma, blank quotation, comma, if, open parenthesis, and, open parenthesis, check underscore 03, equals to, OK in quotation, comma, FCK, less than or equal to 40, close parenthesis, comma, K, multiplied by, open parenthesis, 0.85 multiplied by, SQRT, open parenthesis, 0.8 multiplied by, FCK, close parenthesis, multiplied by, open parenthesis, SQRT, open parenthesis, 1 plus, 5, multiplied by, beta, close parenthesis, minus 1, close parenthesis, divided by, open parenthesis, 6 multiplied by, beta, close parenthesis, comma. If, open parenthesis, and, open parenthesis, check underscore 03, equals to, OK in quotation, comma, FCK, greater than 40, close parenthesis, comma, K, multiplied by, open parenthesis, 0.85, multiplied by, SQRT, open parenthesis, 0.8, multiplied by, 40, close parenthesis, multiplied by, open parenthesis, SQRT, open parenthesis 1 plus 5, multiplied by, beta, close parenthesis, minus 1, close parenthesis, divided by, open parenthesis 6, multiplied by beta, close parenthesis, comma, blank quotation, close parenthesis. Let's go through the simple meaning of this formula, step by step. Argument number 1, first, if function will check the cell check underscore 03. If it finds the text check with double exclamation marks, it will notify us by displaying check bending stress. Argument number 2, this argument contains two sub-arguments. Second, if function dot will check the cell check underscore 03, first. If it finds the text OK, it will calculate the value of tau C when the value of FCK is less than or equal to 40 Newton per millimeter square. The formula is K multiplied by 0.85 multiplied by square root of 0.8 multiplied by FCK, multiplied by square root of 1 plus 5 multiplied by beta, minus 1, divided by 6 multiplied by beta. Here, K is the enhancement factor for design shear stress, or tau c. Argument number 3, this argument is more or less the same as argument number 2. The difference is that here we are calculating the value of tau c when the value of fck is greater than 40. To get the value of tau c, in the above formula, we have to change fck to 40. This is because, as per IS 456, for the calculation of tau c for concrete grades higher than 40, we must use the tau c value corresponding to fck 40. The ultimate portion of this formula belongs to argument number 1. By using blank quotation marks, we are telling Excel that if check_03 is not equal to OK, then the cell should remain blank. By copying this formula, I am pasting on the cell with heading tau c, and we are seeing the value of tau c or design shear stress as 0.821 Newton per square millimeter.
Alright, that wraps up shear stress in doubly reinforced beam. IS 456 Part 03. Today, we successfully completed our dynamically interchangeable Excel sheet for both doubly and singly reinforced beam design for shear stress checks. Instead of adding more time to this video, I'm saving the sheet for the next one. And trust me, when we will complete the sheet, it will work beyond our expectations. Your free Excel sheet. Now, for an announcement many of you have been waiting for, the free Excel sheet I demonstrated previously, the one without detailed explanation. I've received so many fantastic emails, and I'm genuinely thrilled to share it with you. To get your copy, please read the instructions carefully in the description below this video. It's a quick 2-step process. You'll need to email me your request and leave a comment on this specific video letting me know you've sent it. Both steps are absolutely essential. And once you've got the file, a quick "got it" or "thank you" would be a huge sign of gratitude for my honest effort. You're ready to pay it, aren't you? I definitely believe so. Empower your learning. For this entire beam design series, my main goal is to empower you to build your own Excel sheet. Relying solely on pre-made sheets can limit your understanding. Developing your own truly builds your skills and confidence. If you hit any snags while creating your sheet, remember, I'm here to help you completely free of charge. My focus is always on your learning and skill development. Support my work. If you'd like to support what I do, here are 2 simple ways. Watch my videos in full. Consider a contribution, whatever fits your budget, without any pressure. You'll find the details in the description, and the communication process is the same as requesting the Excel sheet. Your engagement genuinely helps me improve how I share knowledge with all of you. Stay engaged and support the channel. I hope you enjoyed this episode. Please leave your feedback and questions in the comments below. If this video helped you, give it a big thumbs up. Remember, sharing knowledge means enhancing knowledge, so please share this video. And if you want to support my honest effort, subscribing to the channel is the best way to do it. Subscribe for mutual benefit. Thanks for your cooperation and support.